In 8.1, we're talking about rational expressions, which are basically just like fractions with polynomials in both the numerator and the denominator. So the first questions that you're going to get are asking what the domain of the function is. And that's basically where any x that you can put in. And so you're going to get something like 7x over 6x plus 48. And what it wants to know is what x's will work. So the way to do this is actually just to find out what x's won't work. And the ones that won't are when the denominator equals 0, because we're not allowed to have the denominator equal 0. So what we're going to do is just solve 6x plus 48 equals 0. So I'm going to subtract the 48, and we get 6x equals negative 48. Divide both sides by 6, and x equals negative 8. So the way you're going to put that is all real numbers except x equals negative 8. So that's what you're going to do on some of the first ones. Another one, you might have 10x squared minus 50x over 10x squared plus 50x. You're also going to get some where it says just to put in a number for x and solve. So we've done some like that. So I don't need to really do another one. Like here, if you put in a 1 for x, it would be 10 minus 50, which is negative 40, over 10 plus 50, which is 60. So negative 40 over 60. Divide both of those by 20, and you get negative 2 over 3. So you get something like that. But here, it's asking you to simplify and ask where it's undefined. And again, where it's undefined is where the bottom or the denominator equals 0. So I'm going to do that part first. And we have 10x squared plus 50x equals 0. We can factor out an x or a 10x, and we're going to be left with x plus 5 equals 0. Okay, now, even though we didn't do any, I did explain in a chapter 7 video that what we do here is set each of these factors to 0. So 10x equals 0, and x plus 5 equals 0. So here, divide both sides by 10, and we get x equals 0. Subtract 5, and we get x equals negative 5. So this is undefined at 0 and negative 5. Now to simplify, what we have to do is factor both the numerator and the denominator and then cancel out what we can. That's what we're going to do on all of these. We're going to factor first and then simplify. Remember that. Always factor completely first. Don't just simplify something. Like here, you see that there are 10s. Don't simplify the 10s. Don't simplify the 50s. Don't simplify the x squareds. And don't simplify the x's. You have to factor first. So, on the top, we can factor out a 10x. And we're left with x minus 5. On the bottom, we can factor out a 10x, and we're left with x plus 5. And now we see we have 10x on both the top and bottom, so those will divide out, and we're left with x minus 5 over x plus 5. If you don't use the math quill, which is the red arrow in the yellow box next to the answer box, you're going to need to put parentheses around both the numerator and the denominator. That's very important to do that, or else it's going to register as something else because of the order of operations or PEMDAS. Okay, then you're going to have something like 21x to the 10, y to the 5 over 9x to the 6, y to the 14. And to simplify this. Now these, we've done these kind before. But here, let's look at the numbers. We have 21 and 9. Both of those are divisible by 3. So that's going to be 7 over 3. And here we have x to the 10 on top, x to the 6 on bottom. So that means our x's are going to stay on top, and it's going to be x to the 10 minus 6, or x to the 4. And on y's, we have y to the 5 on top, y to the 14 on bottom. Since the 14 is bigger, our y's are going to be on the bottom, and it's 14 minus 5, which is 9. So 7x to the 4 over 3y to the 9. Then you'll have questions like 20 over 15 minus 5x, and we have to simplify that. So we can't do anything with the 20 on top, so that stays there, but we can factor out a 5 from the bottom. And what we do when we're left is 3 minus x. Now the 5 and the 20 we can divide, so we're going to have 4 on top and 3 minus x on bottom. Note that I put these in parentheses. That's so that when you type it in, you'll keep it this way, with the 3 minus x on bottom. If you just type 4 divided by 3 minus x, it's probably going to be 4 over 3 as a fraction, and then minus x, because that's the way it's done as for PEMDAS. So you need to put the parentheses or use the fraction tool in the math quill. Okay, so now let's say we have 24x over 8x squared minus 4x. So again, we can't do anything with the top, so we keep 24x. On bottom, we can factor out a 4 and an x, and we're going to be left with 2x minus 1. So now these x's will cancel. 24 divided by 4 is 6, and we're left with 2x minus 1 in the denominator. Okay, then let's say that we have 3 plus 8x over 8x plus 3. Now remember, we have a 3 and an 8x plus 8x and 8x plus 3. Those are actually exactly the same as each other. If we rearrange the top, it would be 8x plus 3 over 8x plus 3. Now that we have the exact same thing, if we put this binomial in parentheses, we can simplify that to be 1. You can only simplify if it's exactly the same, or just one of the factors is. However, let's say we have 14 minus x over x minus 14. Now we have the same thing as each other, except we have minuses in between. So this is the situation that I talked about in the chapter 7 video, where we rearrange one of them so that we have x's on top. So I'm going to rearrange this, so this is going to be a minus x, and it was plus 14 over x minus 14. So now we can't do anything yet, but what we can do is factor out this negative 1, like I had said that we can do. So minus this negative x becomes positive x, this positive 14 becomes minus 14, and it's all over x minus 14. Put that in parentheses. These all cancel, and we're left with negative 1. Now you don't have to do all this work. If you have ever the exact same thing on both top and bottom, but they're reversed and there are minus signs in between, your answer is going to be negative 1. If you have the exact same thing and they're reversed and there's pluses in between, it's going to be positive 1. So you may want to watch this part of it a few more times so that you understand that. Okay, so the next one, let's say we have 6x squared minus 30x over x to the 3 minus 25x. So on the top, we can factor out a 6x, and we're left with x minus 5. On the bottom, we can factor out an x, and we're left with x squared minus 25. Okay, note, x squared minus 25 is one of those difference of two squares, so we can factor that. We're going to keep the top, 6x, x minus 5. We have an x, and then the difference of two squares, we take the square root of the first and the square root of the second. We do that twice and put one with plus, one with minus. So x plus 5, x minus 5. So now what can we cancel? We can cancel the x's. We can cancel the x minus 5's. On top, we're left with 6. On bottom, we're left with x plus 5. And again, if you're not using the math quill, put the parentheses around those. Okay, so next, let's say we have 5x plus 8 over 25x plus 40. So we can't really do anything on the top, so I'm going to put that in parentheses so that we know that it's the whole thing. On the bottom, we can factor out a 5, and when we do that, we're left with 5x plus 8. So now we can cancel the 5x plus 8's. When we do that, we don't have anything left on top, so we need to put a 1, and on the bottom, we have a 5. If you cancel everything on top, that means that you have 1 left there. So make sure you put that 1. Next, 36x plus 20 over 9x plus, 5. Okay, so we can't do anything on the bottom, so I'm going to leave that as 9x plus 5 and put it in parentheses. On the top, we can factor out a 4, and when we do that, we're going to get 9x plus 5. The 9x plus 5's, we have 1 on top and 1 on bottom, so those will cancel, and we're left with 4 on top, 1 on bottom, but we don't need to write that 1. Okay, so next, let's say we have x plus 5 over x squared plus 9x plus 20. So on this, we can't do anything with on top, so we're going to have an x plus 5. We do need to factor the bottom. Okay, so these are sometimes easier than the ones in chapter 7 because we can make an assumption. Assume that x plus 5 is one of the factors. If this second number goes into the third number, and it does, it goes 4 times. And when we add, because these are both pluses, 5 plus 4, we get 9. So x plus 5, x plus 4. You could just do everything that we did before and factor in order to get your answer. But you can make some assumptions on these and make it go a little bit easier. So here we can cancel out the x plus 5's, and we're left with 1 on top and x plus 4 on bottom. Okay, next, let's say we have x squared plus 13x plus 42 over x squared plus 7x plus 6. Okay, so do the one that looks easier first. So I'm going to do this bottom one. And I'm going to have an x plus 6, x plus 1. Because the only factors of 6 that add up to 7 are 1. Then we have to have factors of 42 that add up to 13. And those are 7 and 6. So x plus 6, x plus 7. So now we can factor out, cancel out the x plus 6's, and we're left with x plus 7 over x plus 1. And that is as far as we go. Do not cancel these x's. It has to be everything that's inside the parentheses or as a factor. Okay, now let's say we have 2x squared plus 7x plus 3 over 4x squared minus 1. So I'm going to do the one that's easier first, which is the 4x squared minus 1, because that's a difference of two squares. So we have 2x plus 1 and 2x minus 1. Now let's look at this here. We have, we can't factor out a 2, and we have two pluses. So we know we're going to have two pluses in our two binomials. So let's assume that 2x plus 1 is one of the factors. The other factor of 3 with 1 is 3, and the other factor of 2 with 2 is 1. So this would be x plus 3. And if we work this out, 2x squared times x is 2x, or 2x times x is 2x squared. 2x times 3 is 6x plus 1 times x, which is 1x, which is 7x, and then 1 times 3 is 3. So now we can cancel the 2x plus 1s, and we're left with x plus 3 over 2x minus 1. If you don't really understand the short, or the what I'm saying by making these assumptions, go ahead and just factor everything and then cancel. But remember, factor everything that you can before you do anything else. Okay, so this last one here, x to the 4 plus 5x to the 3 over x to the 3 plus 7x squared plus 10x. Okay, so on the top, I can factor out an x to the 3, and I'm left with x plus 5. On the bottom, I can factor out an x, and I'm left with x squared plus 7x plus 10. On the top, I keep the x to the 3 and x plus 5. On bottom, I keep the x, and I'm going to have an x plus and an x plus. And I need two factors of 10 that add up to 7, and those are 5 and 2. So I can cancel the x plus 5s. And I can also, I have an x to the 3 over x, which is x to the 3 minus 1, which is x squared. And on bottom, I have x plus 2. Again, if you're not using Math Quill, put everything in parentheses like this. So the x squared in parentheses, and then divided by x plus 2 in parentheses.